Welcome back. I'd like to welcome Microsoft Director of Growth, Innovation, and Strategy, Nick McGuire. Thanks for joining us all the way from the UK.
Hello, Leslie. Yes, here at UK HQ. Pleasure to be here. It's late, but the team's here and it's great.
Sweet. Well, thanks for waiting for us. So Satya mentioned in his keynote on day one that Azure is everywhere. What do we mean by that?
Yeah, well, the cloud is expanding into this ubiquitous and highly distributed fabric that's bringing compute closer to the edge, but it's ultimately bringing compute closer to the problems that developers are trying to solve. So what he means is that Azure has become this comprehensive and flexible platform to build these distributed apps that can span not only from the cloud to the 5G edge, but increasingly over time even space as well, which is just wild.
Yeah, it is. And I think other people see that too on Twitter. I saw one that was just like Azure, 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 Azure. So it really is everywhere. But what does this mean for developers?
Well, what it means is actually we're seeing a new category of application emerge, what we're calling modern connected apps. And modern connected apps are these highly intelligent, network intelligent applications that have the ability to interrogate the network and have the ability to ultimately help developers solve problems that they've previously not been able to solve. And I think that's what's really important when we think about this category of application and what's coming with respect to this type of application area.
Great. Now, I also remember back in Satya's keynote that there was a little teaser of a customer, Ferrovial, doing some work that relates to this. So can you tell us a little bit more about what Ferrovial is up to?
Yeah, sure. Why don't I show you a demo of the Ferrovial solution? I think that would be fantastic. So should we do a demo?
Yeah, who doesn't like a good demo?
So highways are becoming more and more digitized to improve safety. So Ferrovial is creating a smart road solution called IVIA, where the road is basically exposed as an API, enabling infrastructure to automatically adjust in real time to changing situations thanks to information from cameras and sensors that are placed along the highway. So this allows Ferrovial to create a digital twin of the highway in real time, which is what you're seeing here. Now, the cool thing is they can offer services to the drivers and expose information as APIs to connected vehicles or autonomous cars. For example, they built a custom AI model for object recognition to identify safety hazards like debris or broken down vehicles. And latency is so critical. A few milliseconds can make the difference in terms of saving lives. So the solution has to be ultra reliable and responsive, which is why it's based on 5G. And using 5G-enabled cameras, sensors, and panels, roads can automatically identify these hazards and respond in real time, such as submitting service requests or updating the signage to inform the drivers. Now, how do you bring 5G and compute to the highway for all of this? Well, in areas further away from the cities, Ferrovial deploys their own private 5G network along the highway using Azure Private MEC to bring compute to those locations. But in other cases, such as updating the digital message signs, they can use an available public 5G network if in an area with 5G coverage. In those cases, Azure is partnering with carriers through our Azure for Operators initiative, so they can provide compute locally to those networks too, what's called Azure Public MEC. So you have Azure Private MEC to extend Azure compute to your own private 5G networks, and Azure Public MEC if you want to use an available 5G network.
Well, shoot, that is really cool. But, as magical as it seems from that demo, what's actually going on behind the scenes?
Yeah, so why don't I show you some of the components in Azure Portal? I think that'll answer your question for you. So why don't we roll the next flavor of the demo?
Yes.
So if I start with the private 5G network, with Azure Private MEC, you can manage several aspects of the network directly from the Azure portal or even programmatically. For example, we can get a holistic view of all the various locations where the private 5G network is active. And if we do a double click, we can see them represented as an edge custom location. Because the solution is deployed as a Kubernetes cluster using Azure Arc, you can manage this type of distributed containerized application in a highly consistent way across on-premises and multi-cloud environments. Now, still in the Azure portal, you can also view and configure all the different devices connected to the private 5G network and set up policies such as quality of service to determine how the network will handle things like traffic prioritization and bandwidth usage. Now, this is just on the private 5G side. But here we can see the same distributed app deployed through several Kubernetes clusters across multiple targets to cover different requirements. So besides the Arc connected cluster we saw previously for the private MEC, we also have our application deployed in regular Azure regions and also in an available public MEC node. The highway here is in Dallas, So we can use the Azure Public Mech node provided by our partner AT&T, and you can see how it is completely integrated with Azure. This cluster will run in AT&T's local compute in their network in Dallas, which is where my highway is connected to. That means very low latency for me to target the critical scenarios such as hazard identification we saw earlier. Now in this cluster, we are running the video analytics model to detect traffic congestion. And what's powering it is a video platform called Edge Video Services, or EVS, along with ML models from Azure Cognitive Services such as spatial analysis. And this provides intelligent video analysis for this vehicle counting application that we saw earlier. Now, EVS splits across private and public MEC or regular Azure regions, and it's optimized to work with 5G to reduce network traffic volume and make the best use of the compute infrastructure underneath. Now, say we wanted to set up a new smart road deployment in Atlanta, for example. Well, we could just deploy our AKS cluster into an available AT&T public MEC node in that location, which is exposed in the Azure portal as edge zones, as you can see here. And of course, we can just use GitHub Actions to automate the CI/CD pipeline, which allows us to automatically deploy the same containerized code base across private MEC, public MEC, and Azure regions in parallel with each code change.
So this is such a great example of a modern connected app powered by 5G in action. Bringing compute closer to the problem that needs to be solved. And in Ferrovial's case, it literally was solving safety problems at the roadside. And because we've got one unified and flexible platform, we have the ability to manage it all through one single pane of glass, which is just phenomenal.
Yeah, that is fantastic and very important work, clearly. So where can developers get started?
Yeah, please go visit us at aka.ms/modern connected apps. You can see it on the screen here, and we'd love to hear from you.
Awesome. Well, Nick, thank you so much for joining us. So now,
thank you for having me. It's been great.
Yeah. So now